So how well can you train a camera to see and respond like a human?
Well, you can actually train a machine learning to be 100% accurate and do anything that a human being can do with their sight. You can outperform a human today.
And where would you say computer vision is impacting the world already today?
Get down to a lab technician, right? They're looking through a microscope to find viruses and things like that. Computer vision can do that type of thing. Robots moving around a factory. They're able to identify a person and so forth so that they can be safe around that person.
All industries could leverage vision.
Hello, welcome. I'm Dalton, and today we're talking with co-founder and CEO of alwaysAI, Marty Beard, and co-founder and CTO, Steve Griset. So Steve, let's dive a little bit more into that accuracy that you mentioned. Is it really dependent on how much data you put in? How much does the actual AI impart when it comes to the quality of the detections?
So the AI definitely plays a role in it, right? That's the whole thing that's driving it. But again, what drives the AI is the data sets coming in. So when you capture the right type of data and so forth, you're going to get a higher accuracy level and perform at a human or above a human level.
Are there specific types of objects that you can recognize easier than others, let's say?
Yeah, obviously, recognizing a snowball in a snowstorm is a hard thing to do, even for humans probably on that. But when you have the right contrast between within a scene, then you'll have high accuracy and so forth. And there's many tools in computer vision that you can use to figure out whether you're at the right contrast levels and so forth. And alwaysAI provides you those types of tools. So you can see your input images and making sure you have enough contrast within the image.
And would you say there's any types of objects that humans could recognize better than a computer?
Probably. On what I mean by that is of course the human mind is more adaptive and so forth. So if you take us into a non-trained environment and so forth, we're able to perceive things a little bit better. But as long as you have a pretty consistent environment that you want to see things, for example, we're able to today on a POS system see 91 different objects. We know whether it's a Coke Light, vanilla Coke, any of those types of things. So you can, through the training aspect of machine learning, you can get the accuracy that you need and perform as well as a human being.
Got it. And by POS, you mean like point
of sale system? Excuse me. Sorry, I can't throw in acronyms without saying them. So yeah.
You mean a contactless checkout system?
Yeah.
Okay.
Exactly.
And would you say there's any objects that a computer or a camera could recognize better than a human could recognize?
Well, I think you're starting to go off the visible light. So cameras can move into the non-visible light, which I mean is infrared scales or into ultraviolet. And with those things, I think in the ultraviolet, you could see that in astronomy. You start to see the universe in a different way that is non-perceivable by the humans. Infrared, the same type of thing. I think we see those on night vision. So it actually enhances what the human being can see or the machine can see.
So why choose cameras as a primary sensor to understand the world?
Cameras, of course, we're talking about vision, so cameras are very good for vision and seeing the world around you. But you can also do what they call sensor fusion, so you can learn more about the world. So what we see in autonomous cars, or even robots in factory, you start mashing them with LiDAR. So you have camera and it starts to give you distance and so forth, how far away an object is, so a robot can reach and grab that object. So yeah, you get the primary vision through the camera, but you can also use sensors like LiDAR and so forth to find out more information to add on top of that computer information that's coming in. But the primary sensor in computer vision is going to be a camera, just like the eyes are the primary sensor for us to see and so forth.
And also, I would add to that what we're seeing, and one of the things that we really try to enable, is leveraging the existing world of cameras. In other words, there's so many cameras out there already that are ready and able to be upgraded, if you will, to enable deep learning AI. Right, so there's just such a huge install base in the world of sensors, cameras, ready to do more, ready to do intelligent things and really help us in our, our personal lives and our work lives.
And would you say when you use this word computer vision, does that describe any sort of analytics through a computer or a machine, or is it a specific type of AI that you mean?
It's a specific type of AI. AI is one of those terms that people throw out there all over, and there's many different types. There's like natural language processing, trying to understand what a human being is saying and so forth. And then as we get into computer vision, it's a specialized form of AI, just like natural language processing. It's trying to interpret the world through, of course, vision, to be redundant here on it. So it's seeing the world, and there are special algorithms that go with that. There's special manipulation. The interesting thing about computer vision is it really has two forms, what we call traditional, which is detecting edges and changing environment and vision, and then we have machine learning. Both of those are classified into AI. The machine learning is the trainable piece of it, so that you add data sets, we call them, or that's just data and that's been annotated, and you train the system on those algorithms to find certain things in that environment. And it does it quite well. With edge detectors, we saw those in what they call machine vision. So as you're welding something on in a factory and so forth, it looks for, oh, I should weld here. And so you have different edges and so forth, and it's designed to detect here's the board, and then it changes on an edge here. And so that's where I'm supposed to go, is in that edge. And that was the earlier piece of computer vision, and these edge detection, changing conditions and so forth, and lighting. And it works quite well in a very constrained environment. But at the same point in time, a learned environment is much better, allows you to have all kinds of varying lighting conditions and so forth. And that's what's really broadened computer vision in its application, is bringing the machine learning aspect of it.
And is deep learning unique to that new capability of computer vision? Is that what's helping to bring us into this?
Yeah, so in 2013, they started these convolutional neural networks out of the University of Toronto. And that gave us a capability to train the systems. And you use the right thing, deep learning. Deep learning uses a convolutional neural network. Yep. Then a lot of times when we go into the post-processing, we use a different thing called support vector machines. And what those are really traditionally clustering type algorithm where we're making a binary decision. Okay, we've seen something, now that something could either be this or that, so let's decide more firmly whether it's A or B, right? So you see both capabilities of machine learning, and you're right. There is a contrast between deep learning and machine learning in the part of the support of vector machines. Both of those are kind of new things that came in the late 20.
Yeah, and it seems like when you look at the spectrum of AI, which obviously just gets so much focus in the technology world and the world in general, computer vision is a really, really unique space, as Steve was talking about, but super powerful. I mean, arguably vision is the most powerful sense that we have. And up to this point, we haven't really been able to automate it in a way that you might be able to automate like natural language processing. And we're getting closer to the point where we can automate it to really take advantage of that power. And that's what makes it such an exciting space, is you look at all the potential applications and you can just see the value that can be provided through deep learning, computer vision.
And this gets important from a macroeconomic standpoint. And what I mean by that is, if you've listening to the news, which I'm sure you do, that we have labor shortages and so forth. So giving computers the ability to have vision allows them to do some of the supervisory skills that where we don't have people there to do them anymore because of a contracting population and so forth. Baby boomers were big, now we're moving away from that generation and they're retiring. And you're going to have to find some way to get those productivity gaps in place. That's why we have a negative GDP. It's not because we're in a recession. We just have negative productivity, and computer vision will help fill that productivity gap by doing some jobs that people used to do, that they're no longer people to do them. So get down to a lab technician, right? They're looking through a microscope to find viruses and things like that. Computer vision can do that type of thing. So
I think that's true. I mean, I think we're seeing that in all of the segments that we're operating. So we're seeing that in construction and manufacturing. We're seeing it in retail. We're seeing it in just all these different segments where the pressure to automate has vastly accelerated in the last couple of years, almost demanding applications like computer vision. And that's what's so exciting about the space, but it's really complicated. So, and we've seen the end-to-end complications. So maybe you can talk about like some of why is it so hard, or up to this point, why has it been so hard to harness deep learning computer vision and really get it on the edge where it can do some work?
Well, one of the things that I would say is that the tools were there, but very complicated. You had to become an expert in the area to understand how to use the tools. So that was one thing, right? Experience curve is another thing. So the time you get to spend with stuff and you start to understand how data sets have to be formed and so forth. And that is the artsy part of let's say, it's of creating these types of models. It's intuitively understanding how do I annotate, how do I get the right level of data, and so forth. And now you're starting to get people that have that experience with data sets and your data scientists. And then, like I said, tools and platforms are emerging like alwaysAI for people to use that bring it down so that my current coder base can use this to create applications. And again, my current data scientists that I have in place can start to look at what's the behaviors and so forth because they have a tool. They now have to write that tool.
And where would you say computer vision is impacting the world already today?
Well, I think we see it in many places right now, and so one of them is in general facial recognition and so forth. Do people belong where they belong? Do I know who this person is? And so forth, and that has become important in our society today. I wish it wasn't, but it is. And then other places we see it are, of course, with autonomous vehicles. We're starting to see, and when I use the word vehicle in a broad sense, not just cars, right? But robots moving around a factory. They're able to identify a person and so forth so that they can be safe around that person. Part of the problems with robots is they're very rigid, heavy, and if they hit a person, they hurt a person, right? So this allows the robots to move in and work with us. So that's becoming huge. Other places, as we said, augmenting workplaces. So again, if we go back to warehousing and so forth, being able to have pickers and so forth that are able to do that piece. So you have, in warehouses, you have the automation of the robots moving around, and then you have the automation of being able to pick the right items and so forth. Where we first experienced computer vision, and we've done it for several decades, that's scanning barcodes. Right? Reading barcodes, now we see QR codes and so forth, and now it's just getting more advanced now. Let's identify objects. You and I talked about point of sale systems that don't need anybody there. They can go ahead and identify the object itself and charge and so forth, which is a lot easier than barcoding because we all have that issue with them. But computer vision has been around for a long period of time, and consumers have interacted with it there. So.
I would also look at it like, computer vision, when we talk about vision and human vision and automating that through sensors and so forth, it's just naturally a quote unquote horizontal phenomena, right? All industries could leverage vision. But the thing that's been interesting is it's a lot of traditional industries doing really kind of quote unquote traditional things like manufacturing or construction sites or retail establishments, so-called quick service restaurants, using computer vision to just automate very simple functions that they've been using humans to do. And when I first got into this, I thought it might be really unusual segments or really unusual applications. Turns out to be traditional industries doing basic stuff using computer vision to just do it better and do it faster and do it more affordably. So that's been interesting to watch it be a very almost traditional phenomena just playing out everywhere.
Right. And what would be an example of, say, a basic application in one of these classic industries?
Yeah, I mean, if you look at retail, for example, and quick service restaurants, so we're talking about, for example, McDonald's or Starbucks or any kind of franchise chain like that, they're obsessed with, okay, how many people are coming into the site? How long does it take to serve them well? It's from the time that they ordered to the time that they picked up their items and they left. And just trying to optimize that workflow, if you will, through the site. That is where computer vision can do a fantastic job identifying each phase of that and really trying to optimize it for the manager of that store. Something that, hits their bottom line if they can improve it, something they're already focused on, but again, a camera and computer vision implemented well can do that really, really easily.
Right. And I can imagine that would improve the customer experience as well if you're spending less time waiting for your burger or your coffee every day.
No doubt. I mean, that's, and you can also think of let's talk about a mall or a large real estate establishment, a place. You want to know if you're one of the stores there, how many people are going by my store, how many people came into my store. Maybe you want to understand the demographics of the folks so you can better serve your customer base or your prospects. So it's just a very simple applications like that can have a really dramatic positive impact on the business.
And how do you do that keeping privacy in mind? Something that our consumers think about all the time.
Super important, big issue in AI and computer vision in general. What we do is we make sure that we provide the tools that a developer would need to create that privacy. In many cases, you have to. It's legally required. And that would be really simple things like blurring of a face, protecting the actual identity of that person, but still getting the right information. That's a distinct individual that went to this part of the store to look at these brands or what have you. So things like blurring or just obvious parts of our platform and obvious things that you need to provide to make sure you protect the individual identity of people.
And you can almost imagine, you think about most CCTV cameras today, they aren't blurred.
Yeah.
So this would even take it one step further and add some privacy on top of that, or?
Yeah, that's right. I think that's a good point. There's actually techniques that Steve can talk about in more detail than me that are actually enabling a little more fine-grained privacy through the use of things like blurring that we've talked about. And again, that's something that we take really, really seriously and something that I think the industry as we go forward is going to have to really pay attention to make sure that we do this. We do it well, we're protecting privacy, it's very ethical, there's the value is obvious and the privacy is also being protected along the way.
Right.
So we've worked with a large mall company and developed a prototype for them on re-identifying people as they move between stores and so forth. And we did a couple of things. One, we're more not doing facial recognition. We made sure it's not a facial recognition, it's a gait recognition, right? So people walk uniquely, move their legs uniquely. And so it's one of the things that, unless you really truly think about it and walk silly,
right.
you're not gonna try to make that unique. So they can come in and get the uniqueness on the gate without understanding who the actual person is, right? And then what I think was important, we had an opt-out to that. So as a person could come in, they could stand in the zone and opted them out. And so because we could capture the gates and things like that, we know not to follow that particular thing and drop them off the list, put them in the exclusion. That's just one example of what we talk. Of course, there's blurring out there and so forth. The other way too, let's say you do go into facial recognition because you want to know the difference between your employees and your customers, right? You can, and you may even want to track how often somebody comes to the store. You can keep the metrics and so forth in what we call a UUID, a random ID out there and so forth. And those random IDs can be used instead of saying something like Marty. It becomes this UUID, which just is unique to that type of store, so they can capture that person without knowing all their addresses and everything else like that. So forth. So there are ways around this that you don't need to know. You can say, well, we know this person has come to the store several times just based upon this unique ID, and not even knowing their name, but you know they're back in your store and they know they like going these places. So
the person then, the customers would be anonymous in that scenario?
they're anonymous, yeah.
Okay.
Yeah.
But you still get the useful information?
Correct, yeah.
Well, I'm picturing, in this opt-out scenario in retail, is that a box that somebody stands in? Or how do you actually opt
so
out
it's
that
it's an opt zone. So you use zoning. It's one of the things our tooling does in alwaysAI. Go to this zone and we won't follow you anymore. We won't track you. We won't give the store any information about you. It's the opting out type of thing. So we could do a zone to opt in, right, which is probably preferable in life, right, to do that. So you can do that too. And like I said, zoning, and they don't have to be continuous or overlapping cameras with our platform and what we do. You can add zones as part of your application using our platform.
And again, I think at the end of the day, like almost any technology trend, the value of the application has to be really obvious and high. And if it is, then you can imagine that more and more customers will actually opt in for some of that value. So for example, when I walk into a Starbucks, maybe I allow Starbucks to go ahead and identify, that's Marty, he likes his latte with almond milk. That's okay, that's value to me, and I'm enabling and allowing that kind of identification. And we've seen that through other trends. So I think the most important thing here is, are we providing the value? Is there a lot of value in these computer vision applications? And I think increasingly every week we're saying, yes, there's a lot of value in this. There's data that the business can take and provide even more value to the customer. So I think we'll see more and more customers saying, I'm okay with you providing that kind of information about me so I can get the kind of service that I needed. And if I'm not comfortable with it, totally fine. Right? You can quote opt out. We're not gonna track you in a way you're not comfortable.
This seems very similar to web analytics, let's say, right? Where you have cookies, where you can either choose to do the personalized tracking, the anonymous tracking, or no tracking at all.
Yeah.
Do you see that similar, that web analytics and computer vision?
Sure. It's a great analogy. I think in many ways we're going from this kind of virtual world web analytics where we know that when we visit a website or we shop, we know that we're being tracked and all that data is being parsed and analyzed a million different ways. We're sort of moving from that to, okay, now we're in the real world and we're starting to get information about activity in the real world that, again, can be analyzed so there can be better applications provided, better value provided, and so forth. So it's a good analogy, and we're definitely, computer vision is having a huge impact on that. I mean, on the edge, that's where the sensors are. On the edge, that's where we live and that's where we work, out in the real world.
And if somebody were to build a computer vision application by themselves and not use alwaysAI, do you think that they would have less of a privacy focus, or they wouldn't be able to use the tools that maybe you two or alwaysAI has put together to enable privacy?
They would have to write the code, right? So that just adds complexity to your application. I think as you take a look out there, there's a lot of, hey, should I just use an open source or should I build my own and things like that. You always have to remember code not written is code that you don't have to maintain. So that's pretty important. You know, from my 35 years of being in software engineering, managing lots of software engineers, that's why we would not go out and build our own database. That's why we wouldn't build our own workflow engine. That's why we wouldn't build our own application server, because that code has to be maintained. And I think the advantage of getting a platform is that you can get, the base platform usually counts for about 50% of the computer vision application that you're building. So you don't have to maintain that 50%.
And what do you mean maintain? When you say maintain, what comes
so
with that?
I don't know software that doesn't have bugs or needs enhancements. So what comes with that is enhancements, adding to that platform. The other side is maintaining it from a bug standpoint. So you hit errors and things like that, those are going to be maintained by that platform provider for you. Just like I expect if I had an Oracle database, they would maintain that for me. Even in the cloud, right? You go to the cloud and those people are maintaining, those vendors are maintaining that system for you.
Yeah, and look, I mean, computer vision, getting it all the way from the data that you need to collect to build that model and train the model, and any APIs that you're going to have to engage to build an application, and then you got to get it running on an edge device. I mean, this whole end-to-end process is pretty complicated. So why would you want to spend all of your time maintaining the basic platform to enable that workflow? You'd rather spend time on the specific application you're trying to build. So I totally agree with Steve. I mean, I think what we're trying to do is, look, we'll do all that work, right? We do that all day. That's what we do. So you, the developer, the company, the business, can focus on the most important application development, right? And that's where your focus can be. You don't have to worry about all the back end complexity. We'll take care of that. And the other thing I would mention is computer vision seems very dynamic. And by that I mean things change a lot. The model changes, you've got new data you want to include, or there's something different or some new information that you want to get about your customer or what have you, or maybe you have a new camera you want to try out. It's a very active development space. So again, that's where you want a platform that's staying on top of that, so you can take advantage of that activity.
Right, yeah. Right. And you mentioned dynamic. That's makes me think almost the world is dynamic, right? And when you use these cameras to understand the world, they also have to be dynamic.
Yeah, absolutely. Right. So the cameras themselves are critical parts of this. They're changing rapidly. And so we as a company need to stay on top of those changes so we can take advantage of those changes. Simple example would be like depth cameras, right? Okay, now I can measure distance between objects. That might be super interesting in manufacturing or all kinds of different applications. So cameras are changing all the time.
Correct, and you need to make sure you maintain the interfaces to that and so forth, and that's what a platform does for you. It maintains the interfaces. It makes you so you don't have to focus on this. How computer vision often fails is not in the platform side. It's in what we call the behavioral analysis side. So as you're starting to build your application, that other 50%, you spend a lot of time in there. So for example, we have a customer that's counting cars going through fast food. It's quick serve restaurants, what they like to be called. But there's a lot of behavioral. So people get this idea, I'm just going to drive from point A to point B. Well, it doesn't always happen that way. We have seen cars go through the wrong direction. And I can't think this is not unique.
So in the drive-through, somebody's going the opposite way.
That's right. So what happens to your counter on that type of thing? Well, if you're just trying to, if you're not spending your time in that behavioral analysis point and all your time in a platform, then you're going to get there and figure out this isn't going to work, right? So it's important to get those data scientists and everything watching behavioral elements.
So why is using a platform like alwaysAI better than trying to build computer vision yourself or your own team?
I think we've talked about that in a couple of aspects. One, you don't have to maintain the code, so the code not written, you don't have to maintain. You can outsource that to us to do, as you would like database to Oracle and other companies like SAP, ERP, things like that. So that's just the basics there. So you don't have to do that piece. So that will help you to get to that other 50% I was talking about of the application, which we don't do, that your coders can do at your company or your consultants or whoever you choose, or even alwaysAI can do for you to build out the application, which is going to generate the ROI for you. So that's why I think it's important to get that uplift of your application and time to market, of getting that 50% uplift that you can get from using a platform. And I can talk about my past, because I was the computer vision guy. Anytime anyone had any type of thing they wanted to do with video analysis and so forth, to build them a platform. That's why I came here and formed alwaysAI, because it's the least rewarding piece of the application. So, and it has to be done almost on a project by project basis if you're in a company, and it gets old after a while.
So what you're saying is, rather than build it from scratch, like somebody would typically, they're 50% of the way completed once they would use something like that.
Exactly. They can focus on building their models. They can focus on, like I said, the post-processing that has to be done once you've detected whatever you need to detect within those. And you just don't have to waste your time doing it. You don't have to worry about camera interface, right? It's already there for you. So.
And also there's the economics, right? So, I mean, you could build up a team of machine learning, computer vision experts, but I think we all know that's expensive, and particularly in this kind of labor-constrained world we're in, that's getting more expensive. That's a big investment that in some ways is just unnecessary, right? You don't need to do that. Now, what you do need is you want your data scientists and you want your application experts, great, but the fundamental platform, you don't need to build a team to do that. We are your team. So somebody like alwaysAI, we're that team. We already have it put together for you. You can already get going and start focusing, as Steve said, on the real value, like right now. And so we're starting to see that shift where there's a little bit more focus on the economics and kind of like, okay, maybe we should consider a platform so we can just focus on the application development.
And I mean, in regards to productivity, right, with those teams, I imagine even if you are a machine learning expert or a computer vision expert, you probably don't want to be spending your time on that first 50% that's just busy work or tedious. How do you really offer value to people who already are experts in the field? How much more productive can you make them?
Right, again, like say for example, you have some new data, you have a new data set, right? You want to train that data set, you want to retrain it, you want to tune it. Okay, great. Why don't you use a platform like ours where it makes that really fast, really easy? So again, you can just focus on the value add part of it, which is the application development and implementation. Or let's say that there's a new, we partner with a lot of different companies like NVIDIA. Let's say there's a new NVIDIA product that is coming out. Okay, sure, you could probably do some work to try to optimize your app for that. We've already done that, right? So you don't have to worry about, you worry more about the application that you're putting out into the world to do things that you need for your business.
And that's something that I can imagine would be really hard for any company to do, have a relationship with NVIDIA, actually be prepared for the next product launch, be ready to deploy applications to them, right? So this would give them that functionality on, way earlier than they could have it themselves.
That's right, yeah. I mean, we're in the middle of that ecosystem every day. So whether it's NVIDIA or let's say it's an Intel accelerator, or it's a Qualcomm platform or what have you. I mean, we're going to stay on top of all of that, right? So again, you the developer don't have to worry about that, right? Again, what you want to worry about is the value out of the application and the business impact that that's going to bring you. So we've always, from the very beginning, Steve and I founded alwaysAI, we've been focused on providing that space, if you will, for a developer to be able to focus on the value add. And not on that end-to-end platform that we built.
Yeah, and I would add, with alwaysAI, you have different on-ramps. So let's say you do have a machine learning engineer, and they're going to build out a specially layered deep learning network, and it adds some type of competitive advantage as opposed to using something, using our platform to do that. You can do that, and then you can come on and develop your application, and we can help you make sure you run it on all those types of devices and so forth, because non-standard models with different types of layers and things like that, they're not going to necessarily run on a NVIDIA device, an accelerator, or on a Halo accelerator, on a Qualcomm accelerator. So we can help you get through that. as you come in, and accelerate still the application development, the running and maintaining of that system when it's out in the field and so forth. So we provide value there. So you can either come in with your machine learning engineers and work with ours using our model training system, or you can develop your own model, because there may be a competitive advantage to doing that. Maybe you found something and your machine learning person knows something and they've got it from academia and something like that with their experience there, that they have something that's unique and so forth. So by all means, drive there. We don't want to, machine learning engineers are valuable, and if you have them and they have something that they're doing that gives you a competitive advantage, then you should use that, and then use alwaysAI as your on-ramps there. Is your actual application that has to be developed, the pre and post processing, the capturing from the cameras and so forth, and then maintaining that application out in the life cycle. So you have many choices when you go with the platform on that.
And that's why, the choices that we've provided, we encourage and we want our developers to code. So sometimes we hear about these, quote, no-code platforms, and I think we have a view which is, look, low code is good, but what we've seen is people want to be able to code. They want to be able to get into and engage with the application that they're developing, and to be able to code that application. So I think we've built a platform where we enable that and we actually encourage that. And if you look at quote unquote no code, we kind of look at that like maybe over time that's no value, because you can't make a lot of changes, right? You can't really engage with the application the way that we think that you need to over time.
So no code is nothing new in the industry. So again, been around 35 years in it, and I see no code solutions in every era that I've been in, starting with Smart Talk, if we go back to that one. And what people really like are the visual designers in that, right? But the problem is, when you go to customize those visual designers, that's when you come into a unique coding platform. So it's not standard, right? So when they have to extend those, it's not standard at all. So you're going to either have to pay them, that vendor, to create that code, or you're going to have to reskill your engineering team to customize it. And as we said, you're going to see behaviors happen out there, and you're not going to be expecting it, so you're going to need to customize. It's just the way the world works, and so forth. So that's always been, and always that customization has been a problem with no-code solutions through the whole software industry. It always comes out at the start, and so the good thing is we know computer vision is growing because they have no-code solutions now. so that means that people are looking to do that type of visual design and so forth, and looks cool, but it gives you a basic application with basic components, and then what you're going to have to do is extend that over the time. You can use a no-code solution from alwaysAI. We have sample apps that will spit out an object detector, a classifier, whatever you need there without you writing any code at all. And then you can go, if you have your data set all annotated and ready to go, you can go into our model training and you can create your own unique object detector and so forth. So we do have no-code solutions in a sense, just not visual. And as Marty says, you're going to extend it. And so the value is you can take that no-code solution from us and you can extend it in a standard way. So if a Python coder is a Python coder, and he'll understand our code right after when he looks at it, he'll know how to extend that code into the application and start building that unique business processes into your application. And they won't have to retrain and learn something specialized.
Right, and it almost sounds like that advanced functionality that you might need, especially in a dynamic world, the advanced functionality to create your own computer vision application probably wouldn't really exist with one of these out-of-the-box no-code offerings.
Again, you're always going to give something up, right? I mean, that something is the ability to adapt to the customize. That's a great word. The solution, and it's going to need to happen, right? Like I said, no way out of the box is thinking that a car is going to go for a reverse. No idea that it's going to need to know it needs to extend its queue because people are walking out behind the building with things, and so you can't really get a time of service and so forth on
and what's going to happen as computer vision penetrates more deeply into all these verticals, the complexity of the applications and the demands on the applications are just going to go up.
Yeah.
And you're going to need a platform that enables you to customize and be more flexible. Yeah. It's just reality.
Yeah. So, and again, like I say, it's always the behavioral analysis of what's going on in that environment. And that's what sight does. Once you start introducing sight in it, you have to understand how the world's moving around you, so forth. Be it an autonomous driving vehicle or, counting cars coming through a quick serve drive-through.
And what role does the edge or distributed computing have in the future of AI?
So it's huge if it's autonomous, right? I mean, you have to be on the edge if for autonomous because you're looking for quick decisions, so forth. Think about a self-driving car. Can you really have the latency and so forth? The other piece that the edge does for you is not only solves all the latency problems and things like that, it also does the cost problem. So if you go up into a cloud and you're inferencing into a cloud, you're always paying for it. It's an OpEx model, right? If you go more to the edge, it starts to become more of a CapEx model. And the CapEx there for edge devices is relatively cheap. You can put a Beeline, a little mini PC out there for about $200 and something. And so you can start to see, you can inference more often, learn more about your data. And inferencing, I mean, running the program and doing the machine learning analysis and so forth. That can happen there at, you look at $200 cost, you're probably looking at, at least $1 each time you're going up to that one. So, at 250 inferences, you're at costs of that device, and then it's just going to go down from there. Right? It starts to get very positive, your return on that, where, again, you have this OpEx model that's just kind of stuck. Right? It's always going to cost you money and probably going to cost you more money over time.
So you mentioned almost two aspects there. One of them was real time. You get some insight in the moment, which might be really important if you have an autonomous vehicle.
Right.
But also important.
Or a robot running over somebody, right?
Robot.
If it's waiting for a response,
right. Yeah. But I can also imagine it could be important if you just want to get that insight fast, right? You want to know what's going on in your facility, in your store, and you don't want to wait for you to send a whole bunch of camera data to a cloud somewhere.
Right, and analyze it and so forth. And again, you're going to be cost prohibited on your solution ultimately because you can't inference all the time. So you don't have the analytics as you're saying on that because we're going to sit there, I got to reduce costs. So you reduce how many times you let that machine learning algorithm go through and look at it because it costs you money each time.
And so that's if you're sending constant requests to the cloud, Amazon or Azure or something.
Choose your vendor, right? So, and then again, you have to also think you have to have quick telecom infrastructure too. So you have to have, to get something quickly and so forth, and to move data off of that, you have to have that infrastructure in place and the reliability of that infrastructure. So if this is mission critical, you can't have just one pipe to the cloud. You're going to have different carriers and so forth, and it gets to be a very complex system where if you're using the edge device and the compute is contained within that device, you don't have to build all that.
This is, like I would say, this is really transformative in the technology space, the edge. If you think about it, we've asked for information through our desktops, our laptops. We ask for information from the cloud. Then we had the mobile. Now we're asking for information on mobile. This is the world now working for us. So in other words, we're entering a kind of a phase where the world is actually performing analytics and providing data for us as citizens or consumers that in some cases we're not necessarily asking for. It's just happening. So this is a huge shift in the technology space. And I think it's a new era that we're entering. It's more visual. It's the outside world, the edge, actually driving analytics and providing us information. In some cases, it might be information we didn't even ask for. It's just starting to get provided to us because we, as business owners or managers or citizens, needed to know it. So it's a fascinating push, out towards the edge where we call it where work and life happens. And again, vision is just becoming a major part of that. And Steve made a great point, which is while that's happening, it's actually more economic as well, because a lot of that intelligence is just being driven on the edge, on the device. And we're not necessarily, in that case, kind of slaves to the cloud, right? It's sort of like, well, no, it's actually happening, out on the edge.
And what's the difficulty that comes with that, though, of trying to manage a large fleet of distributed computers, which at each retail store, each warehouse are providing information? How do you manage that?
Yeah, I mean, like Steve said earlier, you use the expression "nothing for free." I mean, yeah, you've got more complexity. You've got a lot of sensors out in the world. And we're literally talking billions of sensors, right? And let's say all of those are now AI enabled. They're all getting smarter. So you're going to have to maintain them. You're going to have to update that software code. You're going to have to, you're going to have security issues you're going to have to deal with, et cetera. So yeah, there's a lot of things that the industry has to work through as we get there. But it is going to have a dramatic impact on our lives.
Yeah. And so Marty's just talked about why it's important to have a complete computer vision platform, because you're going to have to maintain that complexity. We've talked about machine learning is kind of different in that it's learning. So as you get more data, your algorithm gets smarter and smarter, and so you're going to have to retrieve that data at some point in time to get it up to train into on your larger systems where training does happen up in the cloud. It can't happen at the edge. They don't have enough compute power yet to do that. Mm-hmm. They will soon. Right. But anyway, so you can get your data up there, and again, then I have a new model. I'm going to have to distribute out that new model. I may have a model that covers X amount of sites, but I also have Y amount of sites where it doesn't. So this allows you to have the variance in your models and so forth. You could even have a model to a location, if that makes sense, and so forth. Or an application that's got zoning and so forth we talked about to that particular location. So that's why it's important to have a complete platform like alwaysAI, which does that type of thing, that takes into account the provisioning and the maintenance of those devices. Was built actually to do that from scratch.
Right. That's what I was going to say is, like, we literally have built a platform not only optimized for everything you need to be able to build an app and deliver it, but it's optimized for the edge. Yeah. So from the very beginning, we've created a platform that is edge centric, if you will. It's edge focused. And then just making sure so everything we do is going to try to make that really an efficient, powerful process.
And it gets down to, why a platform and things like that. Again, I'm developing on a Windows system. Marty's developing on a Mac system. That's all covered. If you try to do that yourself, you're going to have to roll for the Mac. You're going to have to roll it. And then, oh, by the way, I want to deploy to a NVIDIA device down there. And then you're going to have to build that. So that starts to be the complexity where if you try to, if you do it yourself, you're going to have to maintain all that code all the time. So it's not maybe just one platform. It could be three right there we're talking about.
And I can imagine, too, in that scenario, as we look at the chip shortage and difficulties in manufacturing a lot of these chips, having options, whether it's Mac, Windows, NVIDIA, Qualcomm, other hardware, that can be incredibly important for a customer who wants to.
Absolutely. And he said it gets you around that supply chain problem, or at least helps you manage it.
Thank you so much for coming on and telling us more about alwaysAI. And if users want to learn more, what can they do?
Yeah, it's been great to be able to talk about how computer vision is really impacting the world. And if you're a company and you're starting to look at this space, we'd love to have you come to our website and learn about computer vision, learn about all the use cases. It's so exciting for us to see different industries and different companies get involved and really take advantage of this amazing technology. So again, we'd love to have you come get to know alwaysAI. We've got a lot of great content available online, and to help you capture the magic of computer vision and really help you impact positively both your top and your bottom line.
So what we can do is we'll post a link below if you want to speak to an AI expert and learn more. Thank you so much.